Hello and welcome to today's session on powerful pairing of Tableau and Microsoft Azure. Thank you for taking the time to join us in this webcast today. My name is Deepika Bhatt and I'm joined by my colleague Nanda, Kumar, Nainadurai. We are both business intelligence and analytics consultants at Thorogood and typically based out of our London offices. Today, of course, we're joining you from separate locations. I'm at our office in Ealing and Nanda at the comfort of his home. Before we dive into today's topic, a very quick introduction for those who do not know Thorogood. We are an independent professional services consulting firm specializing in business intelligence and analytics solutions. We operate as a single organization serving our customers globally with leveraged teams of consultants in our offices in New York, Philadelphia, London, Bangalore, Singapore, and Sao Paulo. All of our consultants are recruited and trained in the same way to develop a unique mix of skills, blending business understanding, technical aptitude, and a deep understanding of analytical tools and techniques. We offer a full range of services, right from BI strategy and roadmaps, requirements gathering, architecture and design, end-to-end implementation, and data services and support for production applications. We also support our customers in user training and empowerment programs. In terms of the technologies we work with, we are an independent consulting firm, meaning we don't align with any one specific technology. We work and partner with most of the major players in the BI and analytics market across backend, frontend, and analytics-driven technologies. Our independent means that we are able to develop well-rounded expertise that allows us to help our customers integrate across technology successfully, as we will also demonstrate with Azure and Tableau in the session today. Bringing attention to the technologies relevant in today's session, we have been a Microsoft Gold partner for over 20 years now. Our partnership gives us a great interface into Microsoft development team. We have open channels of communication from our customers back to the Microsoft dev team and from Microsoft directly to our customers, which we have been able to tap into as and when needed. We have also been a partner with Tableau since 2012, currently a strategic alliance partner, and we were also previously named Partner of the Year in the Europe, Middle East, and Africa region. We have a rich pool of consultants all across Thorogood units with experience in design and delivery of Tableau solutions, including its integration with a range of backend technologies, as you can see on the screen. With that, I hand over to Nanda to deep dive into the agenda for today's session.
Hello, everyone. In today's session, we are going to explore the offerings of the Tableau and Azure toolsets and look at how they integrate with each other. I'll take you through some architectural patterns that use different services in the Azure landscape to cater to a range of use cases and user groups. After that, Deepika will also demonstrate one such integration pattern where Tableau reports are built on top of the Azure Data Platform. And then we will quickly look into a couple of deployment options and wrap up. Let's kick off with a quick overview of the two technologies that we are focusing on today, and let's start with Tableau. Tableau is one of the leading reporting and visualization tools currently available in the market. Renowned for its powerful and slick visualizations, Tableau has sort of come to be known as the gold standard for intuitive and interactive visual analytics. There are four major offerings. Tableau Desktop, which I believe many people today are familiar with, the desktop version offers an on-prem tool for users to create dashboards and reports in an agile development environment while supporting self-service analysis of their data. Next is Tableau Server, which is a web-based visual analytics platform enabling collaboration amongst users along with mobile reporting. With this tool, you have the ability to publish data sources created by users and allow for enterprise self-service analysis on the data with reports created in desktop. Tableau Online is considered a software as a service platform, very similar to Tableau Server, but it is hosted and maintained by Tableau in the cloud. A couple of years back, Tableau released Tableau Prep, which is a data preparation tool allowing you to cleanse and transform data for further analysis in Tableau. Now let's briefly look into the Azure offerings. Microsoft Azure has a large range of services available, as you can see on the screen. The services span many areas like compute, storage, networking, IoT, monitoring and management, and perhaps more relevant to what we are here to talk about, databases and analytics. The adoption of Microsoft Azure is growing at a tremendous rate, and the flexibility and scalability offered by the Azure services is immensely powerful. Many of our customers are on the journey of moving their on-prem solution and data assets to the cloud, and it becomes essential to understand how this integrates with other non-Microsoft technologies. I picked out some of the main services that come into play when we talk about integrating Azure with Tableau. This is a combination of data storage services like Azure SQL Databases, Azure Synapse Analytics, which was formerly known as SQL Data Warehouse, which we'll look into shortly, analysis services, data lake storage, and analytical services like Databricks and HT Insight. Tableau can directly connect to most of these sources. A specific case is the ADLS, Azure Data Lake Storage component, to which Tableau does not have a direct connector. But we'll touch upon this a little later in the session. More generally, the integration between the two technologies is maturing, and it is maturing very quickly. Tableau Server also runs seamlessly in Microsoft's cloud infrastructure, so customers who prefer to deploy all their applications inside Microsoft Azure have a complete solution available from Tableau. Let's now look at some of the typical architectures that have Tableau reporting on top of the Azure environment, many of which are based on our experience delivering solutions for our customers. We have a host of data sources on the left, things like files, databases, cloud, and on-prem systems. We know we are using Tableau as the reporting and visualization tool. There are a number of options available within the Azure stack around the data storage and semantic layer. When designing enterprise solutions for Tableau, it is typically preferred for source data to come through from a single data source. Of course, Tableau has the functionality to join and blend data from different sources, but a single data source tends to offer the most simplistic and performant design. In a traditional on-prem architecture, we would have had a Microsoft SQL Server database serving as the storage and semantic layer, which in the Azure landscape translates to an Azure SQL database to serve the exact same purpose. And then we have Azure Data Factory, which is used to orchestrate and move data from respective sources to the Azure SQL database. This is a pretty basic and straightforward architecture, and perhaps closest to what we would use in an on-prem world. You'll see the next few patterns leverage more of the services and benefits offered by Azure. In the next pattern, we have split up the data storage and the semantic layer. Our data sources are stacked up on the left. We are going to leverage the Azure Data Lake Storage for the data storage layer. As you might be aware, the Data Lake Store is a highly scalable and cost-effective solution for data storage and analytics. This is an incredibly high-performance file system where you have the option to pay as you go, so the cost incurred is entirely dependent on your actual usage. It serves as a central repository for all your enterprise data assets, like a single version of the truth. You can have several applications and users connect to data in the lake, both directly and indirectly. It can be used for either standard reporting solutions or for advanced analytics use cases. Now, data can be segmented in the data lake into different logical folders based on what works for your specific needs. In this case, we have a source and an output folder. This allows access to data in different stages of maturity, be it the original source files or the ones that have been processed and enriched. Data movement between each layer is managed by Azure Data Factory. With many of our customers, we have also used Azure Databricks to carry out cleansing, transformation, and processing operations. This can be invoked within Azure Data Factory itself, providing a single integrated solution. Of course, Databricks can be used for a lot more than just ETL operations, and we have other webinars available on our website which covers in detail the data engineering and data science aspects of it. Tableau does not have a direct connector to the Azure Data Lake Store, as I mentioned earlier, and therefore, we will use an Azure SQL database to serve as the semantic layer to the Tableau reporting. This architectural pattern is very well suited to a structured reporting solution where we can leverage the benefits of economy and scale using the Azure Data Lake Store. Let's take a brief look at Azure Synapse Analytics before we look at an architecture involving its components, followed by a demo. Now, if we take a step back and look at the Azure modern data architecture, we have different components for each step along the way. We use Azure Data Factory to ingest data from multiple sources, Azure Databricks to transform data, and Azure SQL Database or Data Warehouse for modeling and serving data. And then you have a storage layer using ADLS, which is an efficient and scalable storage of all your underlying data. Now, Azure SQL Data Warehouse is not just renamed as Azure Synapse Analytics, like I mentioned earlier, but it is pretty much designed to be more powerful than that, and it is achieved by combining power of Azure Data Factory and Databricks into one single product. So instead of leveraging multiple products, Azure Synapse Analytics encompasses the required tools to ingest, transform, and serve data models. Now, let's look at the basic building blocks, which provides Azure Synapse Analytics its power. Synapse SQL is used to query and analyze data with commonly used T-SQL using both provisioned and serverless models. The serverless model is still in a preview stage. And then you have Apache Spark for Synapse, which enables you to quickly create notebooks with your choice of language like Python or Scala, Spark SQL, or .NET. Here you can write custom logic for your data transformations and business logic. And then you have Synapse pipelines, using which you can build end-to-end workflows for your data movement and data processing scenarios. You can call your Spark notebooks directly using your pipelines as well. And then you have Synapse Studio, which is the integrated development environment, which encompasses all of these tools and lets you to execute all data tasks with a simple UI and an unified environment. Deepika will share some of the features of this shortly. Let's try and leverage what we just discussed about Azure Synapse Analytics and use it in our architecture with Tableau. As Azure Synapse Analytics was recently made available to public and still most of the features are in preview mode, the structure has not been productionized yet, but it will be useful to understand the possibilities that are offered to make an informed decision. First, we have our data sources on the left. As we saw earlier, this pattern also leverages the Azure Data Lake storage for the data storage layer. However, to move data between the logical folders, in this case, source and output, we would be using Synapse pipelines for orchestrating data flow, and then Spark for Synapse to write notebook code. You would need to have your data stored in the semantic layer, for which we could use Synapse SQL, and Tableau would sit directly on top of Synapse SQL. It is essentially a very similar architecture to the one we saw a bit earlier, but this architecture pattern makes use of Azure Synapse Analytics components. I'll now hand over to Deepika for a demonstration on how you can connect Tableau to Azure Synapse and some configurations that you'll need to keep in mind while doing so.
What I'm going to start with is a quick demo of the Synapse Studio itself, considering it's still in preview mode and a lot of you might not have had a chance to look at it before. So first thing what I've done here is logged into the Azure portal, and I have already a Synapse workspace created for this demo. When I go into it, you can see that there's a SQL pool and a Apache Spark pool linked to it. And when I say launch Synapse Studio, it takes me to a single tab, which I can then use to both ingest, explore, analyze, and also visualize the data in case you had Power BI in mind as your visualization tool. So as we were looking at in the architecture, there are different components in an architecture diagram we looked at. Starting from the left, we have the data, then we ingest and transform the data, and finally visualize it in Tableau. So in this case, if I go onto the data tab, as you can see, we have a workspace which basically has our Azure SQL Data Warehouse, and you can look at the structure and the tables available in your data warehouse. What you can also do is link your Azure Data Lake store. So as we discussed that Tableau cannot directly connect to an Azure Data Lake store, so what we are going to do is host our files in a data lake, but then use the Azure Synapse Analytics to actually transform and cleanse the data into a structured format and bring it to our warehouse, and then use Tableau to connect to the Azure Data Warehouse. So if I look at these storage accounts, I've already linked it to an Azure Data Lake store, and it is nothing but a container which can have different folder structures, as we're talking about source and output folders. In this case, what we have done is created a raw folder which gets sales data from which is manually placed into this folder. In a productionized system, this data could be coming in from on a daily or a weekly basis from a source system. In terms of being able to explore data, Synapse Studio makes it quite easy, because what you can do is, instead of going and opening another application or another tab to look at your data lake, you can actually just preview a file right within the Synapse Studio and assess whether you need to use this data, or if you're doing quick ad hoc analysis, it makes it quite simple. Similarly, in case you wanted to explore this data, you can right-click, and there are options for you to use a SQL script directly to bulk load the data, use a notebook using the language of your preference to analyze this data, or create a no-code data flow. So if I just click on a new notebook, as you can see that without having to any hassle or without knowing any of the languages that the notebooks offer, it by default has written a script for me to load the data from this file. And if you wanted to do a further analysis, you can run the notebook and it will give you data in a data frame, and you can combine data from multiple files and do that in the language of your choice. And what happens to these notebooks? You must be thinking that this is a temporary code. What you can also do is, as we go into the Develop tab, which hosts SQL scripts, notebooks, and any data flows that you might be creating. So in this case, what we have already done is created some SQL scripts to give a structure to our data warehouse, create the tables and appropriate indexes, and also load the data from all the files that we were looking at in the data lake. Similarly, if you can see, the notebook which we had just created is also appearing here without having to save it. When I say close, it will give me an option to either discard the changes, but if you think that you would want to use this for future reference, you can also save these notebooks. So this gives you a single area to play with your data, to ingest it, and if you wanted to productionize it, you can also use pipelines, Synapse pipelines from the Orchestrate tab to create standard jobs which will run these data flow transformations. So in one place, in a single tab, what you can do is ingest, transform, and also orchestrate and productionize your data source pipelines to create a productionized architecture. We'll not go into detail into the monitor and manage aspects of it, but we'll jump on to the Tableau aspect of it, that once if you have created your different tables and you have your architecture in place, in your Synapse Analytics warehouse to load the sales data, how do you visualize it in Tableau and connect to Synapse Analytics to build your reports? What I've done here is opened a fresh new Tableau workbook. Keep in mind that this is Tableau version 20.2 because that's the first version which comes with the Azure Synapse Analytics connector. So to connect to a Synapse Analytics workspace, you need to go to the option in connecting to a server. As I click on it, you will see that there's a host of different connectors that are available. And before I go to the Synapse Analytics connector, I'll quickly probably point to the Microsoft SQL Server connector, which has been available for a long time now, which you can use to connect not just to your on-prem SQL database, but also Azure SQL databases. But this does not give you option to this does not give you an option to connect to an Azure Synapse Analytics workspace, for which you need to use this connector. So in this case, what I've already done is filled out the connection string, which you can very easily get from your Synapse workspace. And the database name here is SQL Pool, and I'm just going to enter my credentials and show you how easy it is to bring that data in. All right. So as soon as so you can see it was quite quick, and I've connected to a live database now. In terms of bringing your model and creating the models that you're used to in Tableau, there's been a change which happened in version 20.2, where there's an additional logical layer which has been added to the physical layer that you're used to. So for example, if I bring in the fact sales data, and if I bring in channel, what you'll see is that this line seems to be very different from what you're used to seeing, because you would have seen inner joins, left joins, right joins, and full outer joins, which were previously available. But now Tableau has moved to another concept of a logical layer. And in this case, what it's doing is it's creating a relationship between these two tables, which is not exactly changing the structure of the tables underneath. So join actually was merging the tables and building into one huge table, and you didn't have as much flexibility possible. But in this case, relationships are going to be just virtual relationships which are created on top of the tables and will be accessed only when your visualization needs it. So it's going to make your visualizations faster. It's also going to make your data sets more flexible, because you're not changing the structure of the data sets. And you can very easily look at the right level of detail without having to write any expressions or calculations for doing that. But don't worry, you still have the physical layer available to you. If I double click on fact sales, what you'll see is the structure changes, and you can actually also create joins. So In case you didn't want to create any joins or merge two tables together in your data warehouse, you can still do that in Tableau. And in the physical layer, you can actually change the table. So if I say refresh, for example, so you see it's actually done a join, and you can change the properties of the join as you were previously used to. And on top of that, you can do further logical modeling within the same data source pane. So this is a feature which has just been made available in the version 20.2. So what I'll do is show you the completed model that we created for this demo. So I've linked the fact sales table to the relevant dimensions. What I've also done is change the properties to appropriately reflect the performance and the card referential integrity to ensure that we're using the best possible configuration. What you can also do is, in case your data volumes are not huge and you would like to have your data within the Tableau workbook, you can also work with the extract mode, in which case it will extract and include the data in your workbook itself. Or if you have a huge data volume and you don't want to bring it into your Tableau workbook, you can work on a live connection. You also have the ability to set filters. So your data warehouse might have a huge set of data, but if you're working with a limited region or a limited category, you can also write in code to filter out certain years or certain categories in your for the data that you bring onto your workbook. So this can optimize the amount of data and the visualizations that the data it will be pulled into them. So finally, looking at the end results. So what we have done is, out of the sales data, we have created a few dashboards here to show the company's sales. And apart from that, I think all the other features like filters, measure toggles are still going to be available to you on the front end. And with very simple connector, you can use data from your data warehouse and build visualizations on top of it. With that, I think I will probably end this demo showing how some of the new animations and other details can make your dashboard look great. But overall, I think the power of Synapse Analytics and being able to connect to a huge data lake store using that can enhance your BI and analytics space.
As I mentioned at the beginning, Tableau Server also runs seamlessly in Microsoft Cloud infrastructure. So there are a couple of options available here. You could deploy Tableau Server on an Azure VM, where the setup and process is very similar to deploying on an on-prem server, and this is the most common and recommended approach for an enterprise setup, as it provides the ability to scale up and out and upgrade versions as it is required. There is also a pre-configured deployment option available on the Azure Marketplace that is very quick to spin up, and it is best suited for proof of concepts and similar testing scenarios due to some limitations around scalability. Once again, thank you very much and have a good rest of your day.